Do you want to learn how you can query your Dynamo tables to get back all of one kind of result? In this video, that's exactly what I'm going to teach you how to do. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best developer that you can be. In this video, we're going to be taking what we learned in the last Dynamo update video and add another method called DynamoQuery. Querying is really powerful in Dynamo as it allows you to gather all of the records with a certain key value. This can be used for loads of things, but it makes getting information much quicker and reduces the limitations of some of the other methods, such as scan. So what we're going to do is jump into the code and see how we can set all this up. Now that we're in the code, we can look at setting up our Dynamo query. And the first thing we need to do is stay inside our serverless YAML file and actually make a change to the schema of our Dynamo table. If we scroll all the way down to the bottom, we find the resources, and in here we have our DynamoDB table. This at the moment has an attribute of an ID, which is the primary key. And what we need to do is we need to add a global secondary index. This allows us to create another attribute similar to ID that we can query on. With an ID, as it is the primary key, it needs to be unique for every single record. But with a global secondary index, multiple records can have the same field value, which allows you to do get on attribute and get back an array of attributes that have that value. That'll become more clear when we get into writing the query code. But for now, we need to add some more config to this properties object. We need to add a global secondary index. And this is an array. And we have one thing in this array with an index name. And for us, we're going to be adding an index of game. So we can query on our database, passing in a game and get back all of the scores for that game. So the index is going to be the game index. As well as that, you need a key schema. This again is an array with an attribute name, and the attribute that is going to be linked to this index obviously is going to be game, and the key type is going to be hash, similar to the key type on our primary key. As well as that, we can define the projection. So what this is talking about is which attributes do we want to be returned whenever we query on the game index. For us, we actually want to return everything, so we're going to say projection type of all. One last thing we need to do is, because we have set the attribute name here, we need to say that it exists in the definitions. So in here we can add a new attribute name. So I'm going to copy this. And this time it is going to be game. And a new attribute type of string. Make sure that's all lined up, and that is perfect. So we're saying there's an attribute of game on every single row of our Dynamo table, and that we can query on a secondary index of game index, which points at the game field there. So now we've got our table updated, we can go into our lambdas code and into our common and add a new method on our Dynamo to query. So we have get, write and update from the last lesson. So what we're going to do now is we're going to do the query. So query is an async function. And in here we need to define the parameters. And as we've done with all of these, we're then going to pass that into the document client. So const res equals await document client dot query. Pass in the params, use dot promise, and then because this query will return an array of objects, we need to return res.items, which will be an array, or we need to return an empty array if either res doesn't exist or res.items doesn't exist. So now we need to define the parameters that go inside here. The first one of these is table name, and we're going to start creating the parameters that we need to pass in. As we've done before, we're going to use table name and set the capital table name to the lowercase table name. Here's where it starts getting a bit different. We can now define the index name, and this index name is going to be the index that we found in our Dynamo table, or that we created in our Dynamo table, but we can pass that in as index, like that. As well as the index, we need a key condition expression. And this is a string which, similar to in an update, where we are setting value equals something else, this is the expression to find the parameters or the rows that match this expression. So we're going to use template strings and say that the query key equals H key. So this is just a hash key, as all of our secondary indexes are going to be a hash value. And now we need to provide this attribute in a similar way to how we did it up here. And what we can do is actually just copy the expression attribute value. And in this case, we're going to have colon H key, and this is going to be our query value. All we need to do now is get the query key passed in as a parameter and the query value as well. So now we have this parameters completed. It's going to get passed into the query, return an object which has items on it, which are any rows that match this expression. So now we've got that, we can go and use this somewhere. If we go into our endpoints folder, we can create a new file and call this one getGameScores.js. And the way that this one is going to work is we are going to have an endpoint that we can pass up a name of a game, and it will return us the score for every user that has played that game. What we're going to do is we're actually going to copy the code from the getPlayerScore and then modify it, as most of the code in here is going to be very, very similar. At the top, we have the same table name, and this time, instead of it being a path parameters of ID, it's going to be a path parameters of game. Failed without a game, and a response message missing the game from the path. Here we can change ID there, and there, as well as there, into game, and change this to a const. So we can now get rid of this code here, and so we have the game name. So now what we can do is say that const game players equals await DynamoDB.query. And now we are using that query that we've just added to our Dynamo.js object. So this takes a couple of things. First, it takes a table name, which we have defined at the top of this file. As well as that, it takes an index. Because we're querying on the game index from our serverless YAML, we can copy that and paste it in as a string. Now we have to provide the query key, and for us this is going to be game, as that is the field that is linked to this index. And finally we need a query value, and that value is going to be the game passed in the path parameters. So now we have this game players, we can return that as the result in the 200 response. If we save that, we've now created all of the Lambda code. So we just need to go back into our serverless YAML file and scroll up to our API endpoints. What we can do here is copy the last of our player score endpoints and paste in a new version. So instead of it being update player score, we can select this and change this to be exactly what it is in our file, which is get game scores, and change the path to get-game-scores. And as in our code, we're not looking for an ID on the path parameters, we're looking for game. So change this to be just game. And last of all, because it is a get, change the method to a get method. Now that we have completed our getGameScores endpoint, we can go into our terminal and run SLS deploy, which will deploy our new endpoint. Whilst this is happening, we can head over into our console, where we need to go into DynamoDB and update the table that we already have. If we go into Tables and our Player Points table and look at the items, currently we have 2 items with an ID, a name and a score. We now need to add a new property of game onto both of these. So if you click on the ID field there, you can do it in 2 ways. You can either hit the plus, then amend, and you're adding a string. Or the way I prefer to do it is if you click on tree and change it to text, it becomes a JSON object. I find this much easier to work with. And now we need to add game, and this needs to be a string. And for this first character, I'm going to say that it's going to be Uno. I'm actually going to copy that, as we're going to use that on some of the other ones, and hit save. We can do the same thing for Claire. Go into text, paste in the game of Uno, and hit save. Now, using a query when you've only got one value in the game field seems a little bit silly. So what I'm going to do is I'm going to tick Tom, I'm going to select actions, and I'm going to click duplicate, which is going to copy the value of Tom. And I need to change a few things so this will work. First, we need to have a unique ID for all of our people. So I'm going to add in a new ID, and I'm going to change the game to risk. And I'm also going to change the score from 23 to, let's say, 13. And save that. This is a new game with a new score for the same player. I'm going to repeat the process for Claire. So tick Claire, go into actions and duplicate, change it to text. We need to replace the ID for a new ID, change the game to risk, and give her a new score, let's say of 31. Save that. I'm going to do the same thing again with Tom. So click that, actions and duplicate, go into text, change the ID to something that is unique. We need to change the game to, this time I'm going to go with Cluedo. Tom's not great at this, so let's give him a score of 5. So now we have 3 different games in our game list, and we have Tom and Claire with different scores for each game. And now we can go back into our terminal and see if this SLS has finished deploying. As you can see, this has completed our deployment. So we can scroll up and find our API for get game scores /game, and we'll copy that URL. And instead of heading into our terminal, heading into Postman, inside Postman we can paste our URL and then add a game onto the end of our URL. We're going to start with Uno and hit send, and as we expect, we get back an array of players. We have Claire and Tom with scores of 24 and 23 in Uno, which is exactly what we expect. When we change this game to Risk, we now get Risk with scores of 13 and 31. And finally, if we change it to Cluedo, we get 1 response, and he only has a score of 5. This is exactly what we expect and what we want. If we wanted to add a different way of querying, we could add a new field into our Dynamo table, as well as going into our secondary indexes and create a new one copying this with a new index and the attribute that we set in that Dynamo table. We could then query on that. In this video, we have set up a new endpoint using a new method on our Dynamo object called DynamoQuery. We're now able to query our table and get back all of the results with a certain type, which has meant we've also added a secondary index to our Dynamo table. This secondary index allows us to group records by a single value, which we can then query on to get back those results. This has loads of applications and is used really widely in industry, so it's a great thing to learn about now. If you learned something new in this video, make sure to give it a like, as it really helps the channel and helps more developers like yourselves get to see this video. And if you haven't already, make sure to subscribe down here, as the next video is going to be how to set up scanning on your Dynamo tables. Thank you, and I'll see you in that video.